Right, we might start. Good afternoon, everybody. Just watching the participants come through as we speak. There's a lot registered today for this webinar, 200 plus, and I can see the participant count coming up, so it's about 50. So we might start slowly, and once we get going, hopefully the few latecomers will come along. So today's presentation via HydroTerra is the biochar solution, Australian opportunity. And we're very honoured to have Nigel Murphy with us. He's the founder and director of Earth Systems, and he's well known to HydroTerra and a good friend of our managing directors. We've known each other for a number of years. So without further ado, I'll just do some more introductions. So my name's Steve Dudgeon. I've been with HydroTerra a couple of months. So you have to indulge me if the technology fails me. It's only a new introduction. And so we've got a couple of L plates going at the moment, but hopefully it all goes well. My background is environmental science, specialising in soil and water. My role at HydroTerra is business development management as manager, and also principal in monitoring services. And our presenter today, as I spoke about earlier, is Nigel Murphy, who is the founder and director of Earth Systems. So I'll do the introductions and then hand over to Nigel. Let's go along to the next slide. It's a long bio there, but Nigel is passionate about developing strong biochar sector in Australia. As we said, he's a founder and director of Earth Systems and Cyclic Carbon. His companies have been actively innovating and commercialising technology in the clean tech sector for over 30 years, including biochar. His biochar experience covers product development, IP protection, capital raising, commercialisation, market development. Nigel has degrees in environmental and earth science experience in working in Australia, Asia, China, Africa, and the Pacific. He has provided technical advice to companies, government, financial institutions, and the aid sector, environmental science, clean tech, environmental management. He's an honorary life member of the Environment Institute of Australia and New Zealand, and he was the foundation chair of the Certified Environmental Practitioner Scheme for Australia and New Zealand. And he's currently the chair of the Victorian Clean Tech Cluster and chair of the Australian New Zealand Biochar Industry Group. So well qualified to talk about biochar. A couple of administrative announcements. Please, when you've got questions and answers, please use your Q&A at the top of the screen, not the chat at the bottom. That's what we'll be taking. There's a number of early bird questions. We actually have 20 at the moment. So it'll take a little bit of getting through at the end. The intent is this goes for an hour through to 1:30. So Nigel will talk for 20, 30, 40 minutes, depending how he goes. We'll take questions at the end. We might go a little bit over, but we really want to get through everybody's questions. So just a little bit on why HydroTerra do this. We want to share knowledge of our specialist monitoring suppliers and connections. That's really important. HydroTerra, to us, it's important to facilitate education, and we're very enthusiastic about adoption of our technologies in the future. And we want to lead the industries by understanding the needs of industries. So we look forward to hearing through some of the Q&As and some discussions at the back end. Without further ado, I'm going to stop sharing my screen, and Nigel will share his screen and run through his presentation. So hopefully that will run smoothly.
Thanks very much, Steve, and thanks very much to HydroTerra for the opportunity to present on something that I'm passionate about, which is biochar. Yes, I think it is a great opportunity for Australia. Biochar at the moment, it's a growing, small but fairly rapidly growing industry, and has huge potential in Australia. So what is the opportunity for biochar in Australia? Well, I suppose let's start with the problem. Well, we have a huge amount of biomass waste which is going to landfill. A lot of that is very high quality woody biomass, which is ideal for biochar production. We also have a vast quantity of agricultural residues, which are pretty much underutilised or unutilised in Australia. Some of those, a match is put to it and they're burnt, releasing greenhouse gas emissions. It's not just an Australian problem, it's a global problem. So I read recently that they estimate that 3% of greenhouse gas emissions globally are from agricultural residues. So effectively what we are doing, we're wasting a resource, and we could be producing something like biochar, which sequesters carbon and can be put back into the soil for productive use. And that's important in Australia because our soils they're very fragile and depleted. You know, most of our continent is arid, and retention of water, retention of nutrients is important. We put a lot of fertiliser on our land. A lot of that ends up in the waterways and leads to algal blooms, and it's not economic efficient to be losing nutrients out of the soil like we do. Also, carbon products are highly valued by society and are absolutely integral to our future. So if we look at our products that we commonly use, a lot of them are derived from fossil fuels, including things like carbon black. Many activated carbons come from fossil fuels. So carbon is everywhere in our products. So it's a highly valued product, including things like carbon fibre as well, which are mostly derived from fossil fuel precursor materials. Synthetic chemicals are being used in our for our agriculture and water treatment. Things like polyacrylamide, which is used for water storage crystals, goes into our soils. Again, we're putting synthetic chemicals into our soils, where also many of these molecules are derived from fossil fuels. So there must be a better way, and there must be a way for us to turn our biomass waste into something that's valuable. And Australia probably has this problem more acutely than in some parts of the planet, where it's colder and a lot of the biomass is used to generate heat, for heating of, domestic and industrial heating. So Australia, we don't have such a problem with heat, and so consequently, a lot of our biomass is ignored. So, Steve provided a bit of an introduction to me and to Earth Systems. We started on our biochar journey in around 2009. We really got stuck into it. We were lucky enough to win or to be awarded a grant by the Victorian government to try to turn willow waste, which was a weed in Victorian waterways, into a valuable product, a biochar product, instead of burning that woody willow waste on fields and, creating those greenhouse gas emissions. So that's where we started. We developed our char maker technology. We've patented that technology. It's been a long journey for us. Probably we've only really started for it to be cash positive for us over the last few years. But it's certainly a very exciting industry to be in. And we sort of learned along the way that we couldn't wait for the world to come to biochar for various reasons. And I might get into some of those later. The world, has been slow really to take up what we are convinced is a wonderful opportunity. So we developed part of our company. We started manufacturing the equipment, and we've actually also selling the biochar and the pyroligneous acid. So we realised that we just had to get on with it and make it happen. So what is biochar? Biochar has, if you Google it, you probably get about 10 different definitions, but it's common definition is that it's a charcoal, a type of charcoal used for agricultural purpose. It's typically produced at temperatures that promote surface activation, so approximately 500 degrees Celsius, so higher temperature than normal charcoals. So it releases a lot more of the volatile component and has a higher carbon content than most normal charcoal. Other definitions are that it's obtained from thermochemical conversion of biomass in an oxygen-limited environment. So other definitions don't attribute an agricultural purpose. But biochar today has many uses, including in agriculture, to augment soil fertility, improve plant growth and crop nutrition. And there's a lot of interest also in as an animal feed. It also has other uses in many other uses in industry. And you can think of it as a replacement carbon product for things like carbon black and activated carbon. So there's even been carbon fibre, which has been made from biochar material. And a lot of the interest in biochar really, came from the recognition in the Amazon basin that of these incredible black soils, fertile black soils, and people wondered, why they were so fertile, and the scientists worked out that, that it was weathered charcoal and organic content, and that the people that lived in the Amazon basin created these beautiful soils by mixing the charcoal that they from their fires, bone and compost, and creating fertile soils in an environment which has often very acid leached soils. So this really got the attention of biochar and its potential application for agriculture going. So biochar takes the carbon in biomass that would normally break down and emit carbon dioxide and methane. So when, biomass decomposes, it releases the carbon dioxide and methane into the atmosphere, contributing to our climate change issues. But when you produce biochar, the carbon is in a more stable form, and it can have a permanence that's, depending on you know, what soil it's put in or what purpose it's used, but the permanence can be for thousands of years. So potentially, you know, 1 tonne of biochar can sequester up to 2 to 3 tonnes of CO2 equivalent. And by producing biochar, potentially the energy that is a product or a byproduct of the biochar production, you can create a carbon negative process. So you're actually sequestering carbon as you're producing energy, so which is very exciting. It has been recognised as a negative emissions technologies. Here we've got, you know, back in 2018, an IPCC special report, which you know, identifies that biochar as one of the you know, really key negative emissions technologies, compared to the fossil fuels, where we've been releasing the carbon dioxide into the atmosphere. The biochar can sequester the carbon. However, you know, for various reasons, it just really hasn't had the profile. It's been seen as a bit of a cottage industry, and it hasn't had the profile that some other negative emissions technologies that have not shown to be, many that have not shown to be economic have had, and even the funding that some of those have had. You know, just before this meeting, I looked at quite a key paper from 2019 about negative emissions technologies, and it had 4, biochar was mentioned. The word was biochar was, you know, was mentioned 4 times in 50 pages. So for some reason, it just hasn't had the profile that it deserves. That's starting to change though, which is great. So how does biochar work? Well, it improves water and nutrient retention in the soil. It can hold more than 3 times its weight in water. Biochar has a great capacity to hold cations and anions. It has a huge surface area. It can have a huge surface area, and through things like van der Waals forces, it can hold those molecules, those nutrients in the structure. It also can be a home for beneficial soil microbes. So effectively, it can enhance the fertilizers by storing the nutrients. And as I mentioned earlier, it can reduce the soil emissions with agricultural runoff. The food additive for livestock is really interesting, and in Europe this is one of the biggest uses. And you know, what can be better than the cows eat a bit of biochar and then they poo that heavily back into the landscape, and the biochar seems to help the livestock with their condition and susceptibility to certain illnesses. So there's still a bit of science to go there, but you know, definitely a lot of anecdotal evidence is very strong that particularly for cattle and cows. Our technology, well, we developed a containerized biochar system that could take woody biomass that didn't need to be chipped. So we could take the pyrolysis unit, our char maker, to the feedstock. we've had that technology in operation for well over 8 years, and it's still going strong. We've just put two units into Sweden over the last 12 months, and you know, we honestly attract a lot of interest internationally. We virtually get an inquiry every day for our technology. So how does it work? It's a slow pyrolysis system. You put in the feedstock, you produce biochar, pyrolysis gases and heat, and then you can, out of that, you can develop the biochar carbon product. You can also capture the pyroligneous acid, or, you know, smoke water, and also it's energy positive, so the process generates excess energy. So there's heat that's generated, and potentially you can turn either the heat or the syngas into electricity. And recently, you also had the opportunity of carbon credits. That has been that's come about really through voluntary international schemes that have recognised that carbon credits associated with biochar are drawdown carbon credits, and they have really captured a lot of interest, and their value as a carbon credit is much higher than a normal offset carbon credit. So, yeah, as I mentioned, we've had a couple of batch char makers into Sweden. We've got a batch char maker that's operated in Hong Kong, which has taken woody weeds and turned that into to biochar. Put that char maker in about 6 years ago for the Kaduri Farm and Botanic Garden. We've also developed our continuous char makers, which can take, using the same technological process, take chipped biomass or consistent smaller fragment biomass and turn that into biochar. And we're just commissioning at the moment a 2 tonne per hour system in Hong Kong for the Environment Protection Department, so for the government of Hong Kong. And we're also putting in another unit we're putting in is 500 kilogram per hour char maker into the Yarra Ranges for the Yarra Ranges Council in Melbourne. We've got a number of other continuous char makers that are also being built and commissioned at the moment as well. So the biochar success stories are global. Australia's played a key role in the research and understanding of biochar, but you know, in areas like Europe, there's been a lot of activity and a lot of knowledge that biochar can certainly assist in animal health as an animal feed. There's a growing horticulture and agricultural industry. You know, that's going to be affected by price. As price comes down, more applications will be identified. For water pollution management, the biochar can have very strong activated carbon or activated charcoal properties, actually approaching what is commercially sold as activated carbon. So it can have properties up to, you know, 500 metres squared per gram. It's a substitute for conventional carbon products, and I think as there's an understanding that a lot of those carbon products come from fossil fuels and there's a demand to find alternatives, there'll be more interest in the use of biochar for those applications. It's being used and trialled for concrete and asphalt, and also in other building materials. There's a lot of interest there. It's used in green roofs where you need light materials, high value plantings, and there's a growing interest in biochar derived from other materials that have biomass characteristics such as biosolids, and biochar pyrolysis of biosolids can destroy microplastics and PFAS under the right conditions. So there's a lot of success stories out there. In Sweden, an example where the government really got behind biochar is in Sweden. There's a Stockholm initiative where more and more biochar is being produced, and it's being used by government, both for productive purposes of the plantings of some of their trees in city environments, difficult city environments, having great success there, but they also recognise that it's a way of sequestering carbon. So what is the biochar opportunity? Well, it's about, as I said, turning what is currently waste into valuable carbon products. And, just like activated carbon, there's probably, 100, maybe 1,000 different types of activated carbon. I think in the future there'll be 100 or 1,000 types of different biochar with different properties, different moisture content, different grain size, different surface activation, and they'll be used for different purposes. So we're at the start, and by moving forward and really taking this opportunity, we will enhance our economy, create high-end employment and economic opportunities. Maybe the scale of the industry now is a $50 to $100 million industry in Australia, but it definitely has the capacity to be a $1 to $5 billion industry in 2030, and then much higher again. By taking this opportunity, we will contribute to making our agriculture more productive and our soils more sustainable. As I said, we have fragile soils, and our heavy use of agriculture is undermining the capital, our soil capital. And biochar is certainly something that can be seen as putting capital back into the soil. And we also, in a climate, some would say a climate crisis, where temperatures are increasing, sea level is increasing, carbon dioxide emissions are increasing, and we need economic solutions that can help us sequester carbon. Biochar is here and now. It is economic. So it's a win-win opportunity. So, the question is, why hasn't it taken off as much as what it should have done? Before I answer that question, I just want to, seeing that we're in we've got a group where environmental monitoring and precision science is important. I just wanted to talk a little bit about that precision monitoring and where groups like HydroTerra will be important. Well, the first thing is that not all biochar is the same. It can be produced from many, many different biomass types. And we need low-cost methods, low-cost effective methods for monitoring the properties and qualities of biochar. You know, as I said, carbon content, water content, surface activation, impurities, etc. So there's a lot of opportunity for using technology for us to better characterise the biochar that is being produced. As I also mentioned, it's like adding capital. Biochar is like adding capital. It's not a fertiliser, so we need to monitor and show over the long term how biochar affects soil properties. So it's not, you know, it's not a magic bullet. You don't put biochar on the soil and expect an immediate return. It's something that can complement nutrients. It can help reduce the amount of nutrients you need to put onto the land, but also it can help store those nutrients for when the plant needs those nutrients. So we need good scientific monitoring to demonstrate the best uses of biochar and to just demonstrate where it can be most effectively used. So on June the 21st in Canberra, ANZBIC, and I'm chair of the Australian New Zealand Biochar Industry Group, is launching the Biochar Industry 2030 roadmap. It's going to be an important event for the biochar sector, so I welcome all of you to come and join us if you can. And why is a roadmap needed? Well, the roadmap is needed because the opportunity is large for Australia and addresses a number of key national goals. It helps us address the circular economy, economic efficiency, less reliance on fossil fuels, and a net zero economy. It's also needed to overcome inertia. Believe it or not, there is a lot of inertia in our society. We're slow to take up new ideas. There's a lot of regulatory hurdles that for any new technology, any new approach to get through. And there's also, potentially some vested interests that has certainly held back the biochar sector. A lot of money has been spent on things like carbon capture and storage, big scale ideas that just haven't got off a lot of them haven't got off the ground. We see 1.4 billion going into the budget for hydrogen, more money for hydrogen. Very little, well, virtually no money has gone to ANZBIC from pretty much any government, whether it be state or federal in Australia. It's just seen as almost it just doesn't, because it's an industry with potentially a lot of players and very spread out across Australia, just doesn't seem to get the attention that it needs. So the roadmap is about bringing us together, industry, capital, research and government, to drive the opportunity in a safe and sustainable manner. We have to work together to make it happen. And unfortunately, we haven't worked together enough. So it's not as big an industry as what it should be. We've been certainly, as I said, led in biochar research, and there's been a lot of money pumped into research, but we haven't really grasped that commercialisation nettle. So the technology economic drivers and environmental need are all there. Question is, what are we waiting for? We need to move quickly, because otherwise we will get left behind. We will be buying technology from outside of Australia. We'll be having other people telling us how we can use biochar, when Australia has really been part of the development of the industry. So that's why we need a roadmap. We need to work together and make sure we commercialise this opportunity fully. So with that, Steve, I'm open for questions.
Thanks, Nigel. We have about 20 early bird questions, and we have another 10 on the Q&A there. So we've got 25 minutes, Nigel. So we'll see how we go.
Okay.
I'll just share a screen again. Share a screen. A little bit. So we run through. I'll just read the questions, Nigel. I'm sorry. I'll just read the questions and we'll run through them. We did have a little talk before this. There's a few acronyms that we both not exactly sure what they mean, so we'll do our best. But the first one is, how far away are we from biochar being a registered store of carbon with the ACCU?
Yep. Well, I know that acronym, Steve. That's the Australian Carbon Credit Unit. So the Australian New Zealand Biochar Industry Group put in a submission in September to the independent review there, identifying, asking the question, why has there not been the development of a method for biochar? So I don't have an answer for that specific question, but hopefully it's very soon. And the industry is working very hard with government to try and make it a reality. And I think that there is a much better understanding from government on the value and importance of biochar. So I'm hoping that it will be soon.
Okay. What are the key issues with scaling biochar?
Well, I probably addressed this. I think it's inertia, lack of coordination, bigger interests are louder. So, a lot of the big ideas around carbon capture come from very well-established groups and companies. And, they don't write too much about biochar in their suggested solution. So I think I think government really has to come to the party in biochar. They have to take more of a coordination role. At the moment, they're showing, the regulatory side is very strong. They're finding all sorts of reasons not for biochar not to get up and going, but the encouragement side at an industry level has certainly not been there. It's been there for companies. So, for Earth Systems, we've had support from government and, but not at the industry level. So I think that that's what's needed, is support at the industry level.
Okay. And of course, these are early bird questions. So some of this, as you said, would have been covered in the talk. But what's the difference between ordinary charcoal and biochar?
Well, biochar is a type of charcoal, but it's used by pyrolysis methods and mostly produced at a higher temperature. So it has less volatile content, and the carbon is more permanently captured in the particular carbon structures biochar.
What about emissions created during the biochar process? We might talk a bit in that talk as well.
Well, they should be very, very low if appropriate technology is used. So, and it depends on the feedstock as well. So you need to make sure that the feedstock is the right feedstock and you have the right control technologies for emissions. This is part of the difficulty with the biochar sector, because there's very clean biomass which has a lot less issues than contaminated biomass. So biomass with metals, biomass with plastics needs to be very carefully managed and processed under pyrolysis conditions. So it's controlling emissions. The technology is there, and we can do it cost effectively, and we do that well with our technology.
This is a bit of a similar question, I think, but slightly different. They're talking about what emissions are created powering the process.
Well, the process, once it's going, it's using its own energy to sustain itself, or mostly its own energy to sustain itself, and creating excess energy. So to start the process, you can use biodiesel or diesel. You need some energy form to start the pyrolysis process. And with our continuous units, they can be working 24/7.
Okay. What's your experience with residual contaminants? They've listed a couple there, but during the process.
Yep. Well, something like PFAS is we've shown consistently is destroyed at the high pyrolysis temperatures and thermal oxidizer environments. So it's all about temperature and residence time, and things like dioxins and furans are formed under where there's chlorine. But again, they can be destroyed through the right thermal and residence conditions.
Your views on commercial viability of a centralised versus small-scale decentralised?
Well, it sort of defeats the purpose if you've got to bring biomass and use greenhouse gas emissions, create greenhouse gas emissions to bring biomass to a centralised facility. So we've always liked the smaller scale decentralised approach, and I think that's the one that's going to work in the Australian environment.
An industry close to my heart. They're interested to hear about biochar opportunities in ag, including biochar production, application, and carbon farming.
I think they're huge because there's a lot of waste streams created during for agriculture where the waste is not used. So you could use you can create a virtuous cycle. The waste you can turn into biochar, put back onto the agricultural lands, and you can generate energy for cheap energy for value adding processes. So I think it's a win-win.
What are the preferred pyrolysis techniques and wide-scale adoption of this carbon refining?
Well, slow pyrolysis is a proven economic technology, and there are other things like fast pyrolysis and microwave pyrolysis. But I think that slow pyrolysis, using technology to improve slow pyrolysis processes, is certainly effective. But when we use our human ingenuity, who's to say that we won't come up with other better processes? So, as the industry grows and biochar becomes more valuable to our society, there'll be a lot more innovation and creativity that will find new processes and methods, and that should be encouraged.
You talk about this in your presentation as well, but what are the key areas for market development for biochar across Australia?
Well, I think, there's key opportunities for agricultural residues, forestry waste, and also council waste to be used for biochar. And I think the opportunities are immense, both for horticulture, broad scale agriculture, but also very high value. High value. I mean, we sell biochar and pyroligneous acid for the orchid industry in Australia. So various groups will pick up on the biochar. Biochar can be used as a precursor material for carbon fibre. I think I heard that one of the winners of a snowboarding event, their board was made from carbon fibre that was derived from biochar. So there's all sorts of uses, because biochar is incredibly, carbon is incredibly important to our world. And if we want to wean ourselves off fossil fuels, we're going to have to find alternative carbon sources.
Where is it in terms of EPA regulation of authorisation?
Well, that's a good question. Honestly, it's a nightmare dealing with the EPAs. They ask pretty good questions, but really they're trying to find reasons why things shouldn't happen, rather than actually trying to find opportunities to create an industry that's going to generate good environmental outcomes for Australians. So I just think that they're incredibly well resourced, and the biochar industry is not. In fact, it has very little resource. It's only it's a growing industry. So if a potential project has to wait 12, 18 months, has to spend 100 or 150,000 on consultants to get up and going, it's going to kill a lot of projects. Only the people with deep pockets are going to be able to get their projects up and going. And there aren't too many people in the biochar sector at the moment with deep pockets. So maybe that's going to push the multinationals, maybe the multinationals will end up taking this opportunity just to get through all the costs and the time and the effort. But I would like to see our EPAs just come together and really address this area scientifically and with both a carrot and stick approach. And I don't think that that's happening.
Yeah. Any concerns over HF byproduct toxicity from thermal destruction of PFAS contained in biosolids? There's a few acronyms I don't understand.
Again, it's temperature and residence time through a thermal oxidation process. So if it's done right, there shouldn't be a problem.
Yeah. This is close to another couple of questions, but interested from a government perspective. in what is needed to scale up the industry to assist with net zero goals?
Support the industry, like what we're doing with hydrogen, which gets, honestly, it gets billions of dollars. Really, the biochar industry just needs tiny fraction of that. In fact, for the roadmap, probably looking, if the industry could get $1 million or $2 million a year, it could scale up very, very quickly, because then it could address all the red tape regulatory issues as an industry group, rather than each individual biochar proposed development dealing with it individually.
Yeah, that doesn't sound much in the scheme of things.
Doesn't.
No. Another ag question. Has there been any work done to monetize the benefits of applying biochar in broadacre or a cropping setting?
There are many papers out there, and sometimes biochar is wrongly applied, so it's looked at as a fertilizer, an immediate impact, and often those papers show that biochar doesn't have any value, because over the short term it doesn't. It's a long term. The way to look at biochar, it's adding capital into the soil. It's providing long term, over many years, even hundreds of years, it's providing capital into the soil, like the Terra Preta, which still persists to this day. The activities that created that Terra Preta in the Amazonian basin were activities that are 1,000, 2,000 years old, but the soil, the good soils, are still there.
Question about supply chain from product to the land.
Yeah, I'm not really too sure about that, but yeah, look, I think localized production for localized use.
Yep.
Every second council in Australia should be producing biochar. So hats off to Yarra Ranges Council for being the first.
Question about green space in cities. What would be the best method to apply? So they're talking about calculated carbon sequestration.
Well, I think the best example there is in Sweden, that Stockholm project. So that shows that biochar should be used by every council. Instead of putting the polyacrylamides to make sure that the trees don't die in summer, we should be using biochar, a good carbon product that's going to hold water, hold nutrients. But instead we use this polyacrylamide, which is produced in huge quantities throughout the world.
Interesting segue. Next one, the pyrolysis char from rubber plastic for biochar barriers and opportunities, the use of that.
Yeah, again, not sure completely on the question, but yeah, biochar is is a great product for managing water quality. It can be used for contaminated site remediation. Yeah, it has lots of attributes and applicability. Can it be used? It can be used to most plastics, polyethylenes, and it's if that's under pyrolysis conditions, that will be basically broken down to carbon. PVC is not good in pyrolysis because it's a chlorine polymer, so it introduces chlorine into the system. But yeah, very versatile.
Okay. The economics without carbon credits, the cost.
Well, Yeah, well, certainly the carbon credit side, the voluntary market, pricing carbon credits from biochar at 150 euros a tonne has created got the world's attention. And I think that's it's got the world's attention because groups like Microsoft and Shopify were identifying it, biochar, as a special carbon drawdown credit. So certainly it can add to the economics of the production of biochar. But I think biochar is a valuable carbon product that can be used for many applications. And I think the industry is strong, can be strong without the carbon credits, but the carbon credits will help make many projects go that maybe wouldn't be economic without them. So, and that's what carbon credits are supposed to do. They're supposed to turn projects that are not viable or marginally viable into viable projects so we can sequester carbon.
This is one we're not sure. Are you working on linking the systems to the NEG? Not really sure what that one means.
Yeah, not sure.
Right, we might have to leave that one. We've got a number of questions. We're not going to get through those. We've got 20 questions and answers. Nigel, you've done well. You've kept most of the participants online. So I'm just trying to figure out how we do this Q&A. I'm going to click on this and hopefully don't bust anything. No, we can't do those. Let me just, we might have to check with our admin how we do this next part.
I can see the questions.
Can you?
Do you want me to just?
I might just stop.
Okay, well,
maybe you have a look through the questions and maybe we give yourself another 10 minutes before we call it a day. And pick out topical ones. What we would like to do is, regardless, we will try and answer some of those questions outside of this webinar if we can. So maybe I'll let you, Nigel, to work through some more pertinent ones that haven't been answered through some of this early bird side of it.
Yeah, so surface activation, what's the meaning of surface activation? Well, surface activation is it's measured by how much surface area there is per gram of material. And why that's important is that it can hold molecules. So, for example, charcoal is used as a for odor control. So a lot of what you buy for odor control is actually charcoal, activated charcoal, and it can hold heavy molecules, in the material. So the surface activation is a measure of how many molecules the structure can hold. The cost of a char maker, well, they vary depending, but you're looking at sort of $500,000 to $1 million for a system. The use of wood vinegar, well, it's used to, in the US, one of the biggest uses is to create that smoky taste in when you buy hams and various things, and it's used in condiments. So, but it's a biostimulant for it helps flowering and fruiting of plants. So that's how we use it, and that's why the orchid industry is interested in it. What's the level of contamination accepted to process biomass? Any example of contamination? Does accept food waste? Well, food waste, the key things for pyrolysis is the moisture content so that you can have a self-sustaining pyrolysis process. And also you don't want a contaminated biochar product. It's a waste. So, you know, really you want a good feedstocks will produce good quality biochar that can be used, say, for agricultural purposes. Maybe poorer quality feedstocks can be used in concrete manufacture or asphalt, where they are locked in those materials. How can we get more people, local government, state government, federal governments on board? Well, that's the roadmap. So ANZBIG has been to Canberra, has approached a number of you know, politicians. Unfortunately, our system is very, you know, it's very politicised, to be honest, and so unfortunately, ANZBIG has got to knock on doors for people to take notice and to understand biochar. So the more people that knock on their local politician's door and say, "Hey, do you know about biochar? How, you know, can you help us get biochar out there more?" Is going to help. So that's what we need to do. I think it's just we're very slow. It's inertia, and it takes years, I think, to turn the ship around, which I'm not happy about, but it's the way our system works. So we just need to keep working at it. Probably an idea to present to local government waste symposium. Absolutely, very happy to do that. Is animal waste as economically viable as woody biomass? Well, animal waste, if you pyrolyse that, you can hold some of the nutrients, so it can be a nutrient-enriched biochar. But again, you need to have the calorific value to be able to sustain the pyrolysis reaction. So potentially animal manure can be used, maybe blended with a woody biomass feedstock. Do you know of biochar being used in soil water remediation in the contaminant, i.e. in products such as REM brine? I don't know, but it can be used. And, you know, some activated carbon is, for example, from coconut shell, which is a woody biomass. But you can get the levels of activation. You know, commonly activated carbon has 1,000 metres squared per gram, but you can get very high levels from biochar if the right processes are used. Are you working closely with farmers for climate action? I'm not sure. I know of Farmers for Climate Action, and I think that we do need to work together. So, you know, keen for the Australian New Zealand Biochar Industry Group to work with Farmers for Climate Action, because that's what it's going to take, us all working together. How can we be safe with pyrolysis gas, which is toxic? Well, you know, that's not true. So pyrolysis gases from pyrolysis can then be burnt at high temperatures, and it produces a much cleaner emission than a wood stove in someone's household. So they're the type of misconceptions we need to bust, because it's not correct. Can biochar be used to accelerate composting processes? Absolutely. There's a lot of science, a lot of good science around adding biochar to compost, which improves the compost and also accelerates the composting process. How are pyrolysis units powered? Well, they can be powered. You need something to get the process going. We use diesel, biodiesel for that. Small quantity compared to the energy that is created during the pyrolysis process. Can you feed all organic waste coming from households into the char maker? No. You need a consistent feedstock. You need something that you need to make sure that there are not certain contaminants in there. So it all needs to be controlled and done professionally. But we certainly can take a significant part of the waste stream out of landfill. Absolutely. What R&D approach have you taken to develop our work? Well, we've done it all in-house. So our company employs about 12 PhDs. We've done all the technology development in-house, which is, again, which is not the sort of like the way government sees it, where the R&D is done by universities and then it's spun out and creates companies. That's not how a lot of companies do their own R&D. We've certainly collaborated with a lot of universities. We still are collaborating. We've collaborated on using biochar in concrete just recently. But the model for commercialisation is not just around things coming out of universities. So that's something for Australia to look at, I think. What is the average cost of production per tonne of biochar with your mobile pyrolysis units? Well, it depends on the feedstock and it depends on the whole range of circumstances. So I can't give you one answer, but certainly happy to respond to an email with a more detailed question. But certainly we can produce biochar at a cheaper price than what it can be sold for. What are the key regulatory barriers faced? Well, I can give you one example. One EPA in Australia wants to classify biochar as a hazardous waste. So we get all sorts of charcoal being imported into Australia, sold at Bunnings. Doesn't have any regulatory. It doesn't have to go through any regulatory hoop. But as soon as you're producing biochar in a certain state in Australia, they automatically assume that it's a hazardous waste, which just doesn't make sense to me. It's nonsensical. So that's one regulatory barrier, but there's many others. Is biochar used annually or a one-off process that you add to the soil and monitor the effects? I would love biochar to be used as an additive to a fertiliser. So instead of having just putting your fertiliser, put 1% biochar in with your fertiliser, and then you're adding capital into the soil year on year. So every time you add fertiliser, you're adding biochar. That, I think, that's gold. I think that will make a difference. It'll make a big difference over time. So I think that's the way to use it. Typical application rate, frequency and method. Well, again, that varies depending on the soil and depending on what you're trying to use it for. But my example there, use a small quantity with fertiliser. Every time you use fertiliser, use some biochar. I thought Manningham was the first, Nigel. Yes, Manningham was the first council. Yeah, you're right. So absolutely, Kelly. Yarra Ranges is the second. And in Manningham, we really had the support of an individual from council. With Yarra Ranges, we have the full support of the whole of the council. That's probably the differential. NEG is the national energy grid, biomass fueled renewable energy on site with battery storage. Sounds good to me.
Nigel, you got 6 questions. Do you reckon you'll get through them, and we'll call it
I can try. I can try. You mentioned the use of biochar in concrete and asphalt applications. Is this similar to adding plastic pellets to these mixes, or is biochar used in a different component? Well, it's I was at the ARRB just the other day, and biochar has got a lot of opportunity for use with roads. It's different to plastic pellets and has different properties. It has really some great properties for paving. Whether that's the highest use for the product or not, well, maybe time will tell. But it certainly can replace some of the carbon materials that are used in bitumen. Soil carbon sequestration, ERF projects. Absolutely. Yep. Yes, biochar certainly should be there, and we need to make that happen. How emission generated from pyrolysis process can be avoided? Well, there's always going to be some emissions, but the idea is to make sure that the emissions are within regulatory requirements, within standards, and that's easily achievable. We have cars going on the road every day that don't avoid emissions. They create emissions from the combustion engine. So we need to make sure we have a safe and sustainable biochar industry, and that emissions are avoided. And that's part of what can happen, where we have a certification process for biochar and also carbon credit, carbon credits being generated from biochar through, safe and sustainable production and use of biochar. What are the optimal qualities of feedstock? Low in contamination, consistency, good calorific value. That's what's needed. Yeah. So there's a lot of things out there. And could you please elaborate your work on biochar with concrete? What does biochar do with concrete? Well, I've got a sample that Rajiv from RMIT has just done a paper with our biochar in concrete, putting about 45 kilograms of biochar per tonne into concrete. What it does is it sequesters carbon and it strengthens the concrete. So there's a lot of work and a lot of opportunity there. Again, we're dealing with conventional standards for concrete, using different materials in that concrete. Is a bureaucratic process and a safeguard process that needs to be gone through, which is not cheap.
Done.
Okay.
Thank you, Nigel. That was a magnificent job. Very interesting topic. I think you answered between 40 to 50 questions. I don't know the history of that. That must be somewhat of a record. So there's an enormous amount of interest there. There was still 80 or 90 people still at the webinar at the end of it. So really appreciate your time. I was enthralled by the topic. To me, the secret has always been in the soil, and it's very exciting what's going on. You've got up on screen there, you've got Nigel's email, or if you have any issues, you've also got our contact details to follow up any of those questions. But I appreciate everyone's time. Appreciate yours, Nigel. Very topical. We might have to get you back for version 2 or something. But really appreciate it, and look forward to some more discussion around this and some more funding coming your way, of course.
Thank you very much, Steve. Thank you, HydroTerra, and thank you for the audience for some great questions. And let's move on this biochar opportunity. Thank you.
Thank you. Cheers.